Well, let's finish up with number 43. Suppose that 120 milliliters of argon is collected over water at 25 degrees Celsius and 780 torr. Compute the volume of the dry argon at STP. Now, just like number 42, we're going to have to use Dalton's law of partial pressures to essentially get P1, the initial pressure, but we're going to have to use another gas law after that to do our calculation. Now, let's get that initial pressure out of the way first. So we need the pressure of the water vapor. So let's go over to our table in the back of the book. 25 degrees Celsius, 23.8 torr for that vapor pressure. 23.8 torr. All right. And so if we're going to calculate the volume of that argon, right, so pressure of argon is equal to the total pressure minus the pressure of H2O, which ends up being 780.0 torr minus the 23.8 torr. And that ends up being 756.2 torr. And yes, go ahead and use all four of these values because we're adding and subtracting, so we're just counting how many decimals are past, or how many places are past the decimal. All right, so go ahead and use that. Now this is going to be our P1. Okay. Now let's look at what the question gives us so we can figure out which gas law to use. So we have V1. Compute V2. Okay, so we're going to have to use a gas law that has V1 and V2 in it, obviously. Okay. We also have STP, so standard temperature and pressure. So we have a T2 and we have a P2. So we have 1, 2, 3, 4, 5 things. Okay. Wait a minute. We actually have a T1. Now I need to turn that into kelvins, but that is an initial temperature, right? It's not our final temperature. We have a different temperature to end in. This is the initial one. So that's 298K, and this is T1. So we actually have 1, 2, 3, 4, 5, 6 values present. That's the combined gas law. So I'm going to use the combined gas law to solve for V2. It'll look like this once you've actually done the rearranging, and you can refer to some of my earlier videos if you are forgetting or not sure how to do that. Sorry. So, no, sorry, that's Boyle's law. I'm copying down the wrong thing. Maybe I should do it. V2 is equal to T2 times P1, V1, divided by P2, T1. Now if we start plugging in these values, okay, we're at standard temperature and pressure, so it's 273K. Okay, 273K. We have to be in K, not Celsius. Pressure 1 is what I calculated at the beginning of this problem, 756.2 torr. And then V1 is given to me by the problem itself. P2 given to me by the problem itself, that's standard pressure, but I want it in torr, so 760 torr. And then our initial temperature, which was the 25 degrees Celsius, but we want it in Kelvin, so 298K. Alright, we got a lot of numbers to plug in here, so let's get started. 273 times 756.2 times 120 divided by 760 is 298. And come up with, let's see, we'll go 3 sig figs, 4, 3, 3, 3. So I'm going to report this in terms of 3. So I'm going to drop that 0.3. I'm just going to go 109. 109, and the K's cancel, the torr cancels. Milliliters are the only thing I am left with. So keep in mind that it is very possible that I'll give you a question that you might recognize as Dalton's law of partial pressures, But the way I ask you to answer, give the answer, your final answer, you may have to use a second gas law after Dalton's law of partial pressures.